The primary failure vector in JWT integration is misplaced trust in the token structure itself. A token is only trustworthy if its signature is cryptographically verified against the correct public key or shared secret, and if the issuer claim matches the expected authority. We must immediately reject tokens using the None algorithm header, as this bypasses all integrity checks. Before touching claims, extract the signing key identifier, the KID header parameter. This identifier dictates which specific public key from the JSON Web Key Set or JWKS endpoint must be used for signature verification. If the KID is missing or points to an unknown key, the token is invalid immediately. Never assume the key is static. Always fetch the JWKS dynamically and cache the keys based on their KID for performance, but respect the cache control headers provided by the authorization server. Signature verification involves three components: the base64 URL encoded header, the base64 URL encoded payload, and the base64 URL encoded signature. Concatenate the header and payload using a period separator to form the signing input. This input string is then processed using the algorithm specified in the ALG header, typically RS-256 or ES-384. For asymmetric algorithms like RS-256, the public key retrieved via the KID is used to decrypt the signature and compare the resulting hash digest against a hash of the signing input. Crucially, the implementation must prevent signature malleability attacks by strictly enforcing the expected algorithm. If the token claims RS-256, but the system expects HS-256, reject it immediately to prevent potential key misuse.
Enterprise systems rely on key rotation for security hygiene. Your validation service must dynamically consume the JSON Web Key Set endpoint provided by the identity provider. The JWKS endpoint returns an array of JSON Web Key objects. Each key object must contain the KID, the key type KTY, and the modulus N and exponent E for RSA keys. Implement a robust caching mechanism for these keys, indexed by KID. Set the cache expiration based on the cache control or expires HTTP headers returned by the JWKS endpoint, typically measured in seconds. If signature verification fails, immediately attempt a forced refresh of the JWKS cache before declaring the token invalid, accounting for potential recent key rotation. This prevents transient failures during key rollover events. Once the signature integrity is confirmed, proceed to mandatory claims validation. The IS, or issuer claim, identifies the principal that issued the JWT. This value must exactly match a predefined, trusted uniform resource identifier configured in your application settings. Mismatching the issuer means the token originated from an untrusted source. Next, validate the AUD, or audience claim. This claim specifies the recipients for which the JWT is intended. If the token is meant for your specific resource server, the audience claim must contain your resource server identifier. If the AUD claim is an array, ensure your identifier is present within that array. Reject tokens where the audience claim is missing or does not include the expected recipient identifier.
Time-based claims prevent replay attacks and ensure token freshness. The EXP, or expiration time claim, defines the absolute time after which the token must not be accepted. Compare the current server time against the EXP value, which is represented as a numeric date, seconds since the epoch. The NBF, or not before claim, specifies the time before which the token must be rejected. Crucially, implement a small configurable clock skew tolerance, typically 30 to 60 seconds, when comparing these times. This tolerance mitigates issues arising from minor time synchronization differences between the issuing server and the validating server. The IAT, or issued at claim, is informational but useful for logging and calculating token age. Beyond standard claims, enterprise integration often relies on custom claims for fine-grained authorization. These claims, often prefixed with a namespace, uniform resource identifier to prevent collision, carry application-specific data, such as user roles, tenant identifiers, or permission sets. For example, a tenant ID claim dictates data segregation. Validate that required custom claims are present and adhere to expected data types and formats. Furthermore, check the scope claim, which is typically a space-separated string listing granted permissions. Map these scopes directly to the resource access policies enforced by your application programming interface gateway or service layer. Failure to validate required custom claims results in an authorization failure, even if authentication succeeded. Even validly signed and unexpired tokens can pose a threat if they are replayed after a security event, such as a forced logout. The JTI, or JWT identifier claim, provides a unique identifier for the token. Utilize this claim to implement a token blacklisting or revocation mechanism. When a token is revoked, its JTI is stored in a high-speed persistent store, such as Redis, with an expiration matching the token's original exp time. Before granting access, check if the token's JTI exists in the blacklist. This is essential for handling immediate session termination or credential compromise scenarios, overriding the standard expiration time defined by the X claim.
A critical vulnerability arises when a validator accepts a token signed with an asymmetric algorithm, like RS-256, but then allows an attacker to change the header to a symmetric algorithm, like HS-256. The validator might then attempt to verify the signature using the public key as the secret key. To mitigate this, strictly enforce the expected algorithm type based on the key source. If the key was retrieved from a JWKS endpoint, it must be treated as an asymmetric key, and only asymmetric algorithms are permitted. If the key is a pre-shared secret configured locally, only symmetric algorithms are permitted. Never allow the algorithm specified in the token header to dictate the verification method used by the system. Selecting a robust, well-maintained JWT library is non-negotiable. Avoid implementing cryptographic primitives yourself. Libraries must handle base64 URL decoding, signature verification, and standard claim validation automatically. Configure the library to explicitly define the set of acceptable signing algorithms, rejecting any token using an algorithm outside this whitelist. Ensure the library supports dynamic JWKS fetching and caching, and allows for the configuration of clock skew tolerance. For Java environments, consider libraries like Nimbus JSON plus JWT for comprehensive support. For Node.js, use JSON Web Token, but ensure you manage key fetching externally using a dedicated client to maintain control over caching and key rotation logic. Effective error handling is crucial for debugging integration issues. When validation fails, log the specific reason: signature mismatch, expired token, invalid issuer, or missing required claim. Do not return verbose error details directly to the client, as this leaks implementation information. Instead, return a generic unauthorized status, such as HTTP 401. Internally, log the token identifier, the failure type, and the time of failure. Implement monitoring alerts for high volumes of validation failures, which often indicate key rotation problems, clock synchronization drift, or potential attack attempts against the authentication flow. This operational visibility ensures system stability and rapid incident response.